Hi everyone, this is Mr. Chang, and in this video we're going to take a look at the logical AND in Lua. So previously we learned about conditionals, we looked at different variations of the if, else if, and else, and we also looked at relational operators. With logical operators, we're going to combine conditional statements. So inside of Lua we've got the AND, the OR, and also the NOT. Now, first off, let's go ahead and create a script under Workplace so we can test out our code. So go ahead and in Workspace, click on the plus, and then go ahead and add a script. So logical operators join two or more Boolean expressions. So for example, here I've got x greater than 0, and I've also got y greater than 0. And let's say we wanted to combine them. The logical AND returns true if both operands are true and false otherwise. To help understand logical operators, it's useful to draw a truth table. Truth tables are ubiquitous in the study of logic as they provide an efficient way to determine the result of logical expressions. So a truth table looks like this. So classic truth table notation, we've got P for condition 1, and we've got Q for condition 2. And then over here, I've got all the different variations, all different combinations of P and Q. So I've got true and true, true and false, false and true, and also false and false. Now the rule here is that P and Q is true only if both P and Q are true. So let's take a look at the first line here. So we've got true and true. So by definition, true and true is true. In the second line, we've got true and false. And because we have a false there, P and Q is now false. In the third line, we've got false and true. And again, by definition, because one of them is false, the entire expression is false. And in the fourth line, we've got false and false. And again, because one of them is false, the entire expression there is now false. Now, Lua uses short circuit evaluation, meaning that if the first operand of the expression is true, is false, Lua knows that the entire expression will be false. So again, kind of an abbreviation of the truth table that we just saw. If either one of the P's is false, then the entire P and Q will also be false. Now let's go ahead and replicate the truth table using code. So let's go back to Roblox Studio and let's go ahead and type out some code here. So I've got example 1 and I've got, let's say, print example 1. And here I've got print true and true. And I've got my string concatenation. Now I'm using something new. I'm using a method called toString. And if we notice here, it gives us a message as we're typing that toString provides the value converted to a string. Now, the reason why we're doing this is because when our true and true is evaluated, what's returned is the Boolean true or false. And this is different than the string true or false. And because we're using string concatenation, we do need to print out a string. All right, so let's make the other combinations here. So we've got true and false. We've got false and true. And the last line here is false and false. Now let's also change this to the appropriate values here. So I've got false, 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 and false. So again, this is our truth table, but now we're testing it out inside of Roblox Studio. Let's go ahead and run this here. And if we notice, we look down here as the results, we've got true and true is true, true and false is false. We've got false and true is false, and we've got false and false is false. Now, I do want to just show you if we took away the toString here, let's take a look at the error message that Roblox Studio gives us here. So again, Roblox Studio says attempt to concatenate string with Boolean. I click on this, it brings us to the exact line that this is happening here. So again, the result here is not the word true, it's actually the Boolean true, which is different. And that's why we have to add the toString method ahead of it in order to change it to a string so that we can use string concatenation. All right, let's take a look at the second example here. So let's try the logical AND with two variables, x and y. So if x and y are greater than 0, let's print out both x and y are greater than 0. So per our truth table notation, we've got P as the first condition, and we've got Q as the second condition. So this is very similar to what we had before, except now we have an expression. Now, per the Lua operator precedence chart, we don't necessarily have to have parentheses around the two expressions because relational operators are actually higher than the AND. So again, I'm just going to make myself disappear for a second here. If you look at our Lua operator precedence chart here, from top down, as per previous lesson, the relational operators are ahead of the AND. So therefore, we don't necessarily need to have the parentheses over here. But as I mentioned before, if you don't want to, let's say, memorize this chart here, you can just simply put parentheses around it. Now let's go ahead and go back into Roblox Studio and let's go ahead and try this code out. So I'm going to comment out this. I'm going to add example 2 and we'll print example 2 and we'll say local x equal math.random. And we'll make numbers from -10 to 10. We'll say math.random, -10 to 10 again. And now let's go ahead and create our expression here using our logical AND. So we've got x greater than 0 and y greater than 0. Then we'll print x and y are both greater than 0. Else we'll print out a message here and we'll say print x and y are not both greater than 0. Adding a period here for punctuation. All right, let's go ahead and try this code out here. And I don't necessarily know what's going to happen here because we are using random numbers. And I'll just add a space right over here. So in our first try, we've got 3 and -1 are not both greater than 0. And that's right. Every time we run this should be different. Let's try this again here. And we've got 10 and -10 and 6 are not both greater than 0. Let's just see if we can get to both greater than 0. And here we go. So we've got 2 and 1 are both greater than 0. All right, let's take a look at the third example. So we've got if humanoid endpoints are more than 100, you win a special item. Else, print, you do not qualify. So again, we've seen before the if humanoid pattern will be used extensively inside of Roblox Studio. All right, so let's go back to our Roblox Studio here, and I'm going to comment this out. And I'm going to say example 3. I'm going to say print example 3. And now I'm going to declare here local humanoid. And I'm going to say I am a humanoid. And I'm also going to say local points. And just for argument's sake, I'm going to say math.random, and I'll give myself a kind of equal opportunity close to see it if I have enough points. So we'll say here if humanoid endpoints greater than 100, then we'll print you win a special item. Else we'll print you do not qualify. All right. And we'll also print out, because we don't necessarily know what the points are, we'll say print points and points like this, just so that we know what the value is. Print statement, always very useful. So we have here points. We happen to roll 141, and so therefore we win a special prize, because both humanoid is true, and also this expression over here, points greater than 100, is also true. All right, I hope this helps, and I'll see you in the next video.